analysis and Fourier domain and sampling theorem. But before that, Suketu has posted some questions and he would like to discuss some. Suketu.
Yeah, so just one question that I wanted to discuss, and it has lots of subparts. And yeah, so we have 5 important properties of systems that we discussed in module 1. Just quickly recollect them. Causality. Linearity is a combination of 2 things. What are those? Stability in the Bibo sense. Shift invariance or time invariance, whatever. So you would expect that all of these are independent, right? And by independent I mean that if a system has one of these, you cannot directly say that it has the other. So naturally you would want examples ki, is there a system which is additive but not homogeneous, but stable but not shift invariant, but causal, and so on. So in such a way you should be able to construct examples of 32 such systems, right? Because you could have yes or no to each of these 5 properties. And so that is the assignment that was given in the group. Yeah, so for example, let's start with a system that has none of these. Okay, so any examples? A system which is not causal, not additive, not homogeneous, unstable, and shift variant. Any guesses? Anyone has examples? Sorry, why? AT. No, but it should be, so I have a signal x of t and to it I am associating some signal y of t, right? So what is y of t in terms of x of t? X of t plus ax of t plus m. Oh, outside, okay. Which property, does it satisfy none of these properties? It satisfies causality, right? What is causality? If you can determine the value of y of t if you have access to the current value of x of t and all values of x of t before that. That is called causality. So this is causal, so this is not an example. Now suppose I replace it with x of t plus 1. Does it satisfy none of these properties? Definitely it's not additive, it's not homogeneous. Is it stable? It is stable. Why? Because if I have an input x of t which is bounded, then y will also be bounded, right? Because y will be which is a finite real number, right? So it is stable. So now you need to convert this into something which is unstable. So how do you do that? So a simple thing to do is, okay, you could have a constant, or what you could do is you could multiply it with the, does it satisfy any of these properties? For simplicity I will remove this a also. Y of t is t e to the power of x of t plus 1. Is it causal? Is it additive? Homogeneous? Stable? Why is it not stable? Correct. So if I just give x of t equal to 1, then itself you have an unbounded output, because y of t is equal to t, which is unbounded, right? So it's not stable. Is it shift invariant? So how do you check for shift invariance? So if I have this system, I will give x of t minus t0 and I should get y of t minus t0. But are we getting that? We are not getting that. Why? Because of this factor of time. Right. So this is our first example which satisfies none of these things. Okay. Causality, additivity, homogeneity, unstable, and shift variant. Now suppose I want just shift invariance and I want none of the others. Can you construct such an example? Think about it, maybe 2-3 minutes. See if you can come up with such an example. It should not be any of those. It should be just shift invariant. It should be non-causal, non-additive. Yes. This. It's stable, right? So definitely it's not easy to find out.
First we take a system which has all these properties.
Okay, so let's take that.
And then we go by it.
Okay.
We will get easily.
Sure, sure. What do you start with? So there's no easy way to sort of determine. So for causality, if you want to avoid, you just whatever x of t you have, you just replace it with x of t plus 1 or x of t plus 2. That much you can do, right? Unstability you want. So if I have some bounded input, right, and I want to make the output unbounded, what are some ways to do that? So for instance, if I put x of t in the denominator, and if x of t is approaching 0 somewhere, then my output will grow unboundedly, right? So let me try this. Just, I am trying. Is it causal? It's not causal because it depends on t plus 1. Is it additive? Clearly it's not additive because x of t is in the denominator. It would be homogeneous if this value was 0. But now because this is non-zero, if I scale x of t with some constant and I scale y of t with some constant, then this constant is also going to change. So I won't get y of t minus t0. So it's not homogeneous. Is it stable? It's not stable. Why? Because if x of t approaches 0, x of t plus 1 approaches 0, you see that y of t grows unboundedly. So it's unstable, and you can check that it's shift invariant because there's no factor of time involved, right? So this is an example which is just shift invariant and it has none of the other 4 things, right? So that way you should be able to construct 32 such examples. Now we don't have much time, so what I'll do is I'll just take one example of each. So let's do the easy ones first. This we've done. Now give me a system which is only causal and has none of the others. This is very easy to do. Just right, I just remove the non-causal. Yes? Yeah. No, so if x of t plus 1 tends to 0, then y of t grows unboundedly, right? I'm not talking about the value. See if, correct, but it will grow unboundedly now. See if this is my x of t, near this, y of t will grow unboundedly now. What does unbounded mean? Means that for any real number, if I have some signal x of t and I say unbounded, for any real number r, correct.
So if it's tending to 0, it will always, we will consider it 1, na?
I mean, if it's tending to 0, it will tend towards nothing. Minus infinity and plus infinity are not real numbers. See, I'll tell you the definition. Correct. Exactly. So let me tell you. See, what is the definition of an unbounded signal? If I say x of t is unbounded, that means for any real number r, I can find a time t such that x of t is bigger than r. Can I do it with this? So I can always go close enough to the point where x of t plus 1 is 0, which will make y of t as big as I want. Right? So in that sense it is unbounded. Unboundedness never considers values at points. So in some sense it's like saying, you know, y of x is equal to 1 over x, where x is not 0 and 1 otherwise. Is this a bounded function? It's not bounded, right? Because you can achieve arbitrarily high values using y if you get close enough to 0. That is what stability or instability means. So 3 cases we've done: causality, shift invariance, and none of them, right? So can you give me a system which is only additive and none of the others? Yeah, so I have constructed 3 systems I've constructed so far. One in which none of these 5 hold, right? That was tx to the e to the power of x of t plus 1. If I want just causality to hold, I will remove the non-causal part of this and none of the others will hold. If I want just shift invariance, then this is an example, right? So this is done, this is done. Now give me an example which is only additive and none of the other 4. Non-causal, non-homogeneous, unstable, shift variant and yet additive. So typically if you want additivity but not homogeneity, the typical thing to do is you just consider conjugates. So consider this system, y of t is equal to complex conjugate of x of t. Is it additive? Is it additive or not? It is additive, right? Because for complex numbers a and b, a bar plus b bar is a plus b bar. A bar denotes the complex conjugate, right? So this is additive, but is it homogeneous? So if I put cx of t, I will actually get c bar x bar of t. So this constant is different. So this is not homogeneous. So this is the typical way to construct systems which are additive but they are not homogeneous. So keeping this in mind, can you construct an example? I want only additivity and none of the other 4.
That's an example, right?
No, it's causal, no? It's stable also. I want just additivity. I don't want causality, homogeneity, stability or shift invariance. I want none of those, just additivity. Integration, the problem is I want my system to be operable on all signals. So in general, a system S so if you consider the set of all functions from real numbers to complex numbers, I want my system to be a function from this set to itself. And if you assume, if you put integration and all, then you assume that your signal is integrable, which need not be the case, right? I mean, there are non-integrable signals also. Correct. Yes, but I want the system to be applicable on all signals. There are some signals for which your system will not be applicable, no? The signal integral does not exist, how will you pass it through that system? That is why I don't go for differentiation also, because that assumes that the signal is differentiable. Yeah, so any ideas using this construct? Okay, correct. Right, so what is the system you are suggesting? Huh? Right, but what is the... Correct, but are you sure it is not stable, it is not homogeneous, it is not causal and all that? Have you checked? Because I don't want any of those. Right, so using this construct, I'll give you that example. Again, don't blame yourself if you can't come up with these, because they are genuinely, you typically think, additivity and homogeneity are not independent. That is what intuition tells you. It's not easy to think of this, but actually they are independent. So the system we'll see is it additive? Is it additive? It is additive, right? Is it causal? No, because it depends on t plus 1. Is it stable? It's not stable, because if time is very small, you can make it unbounded, right? So it's not stable. Is it homogeneous? Again, because of this one, it's not homogeneous. And is it shift invariant? because there's a factor of time, it's not shift invariant, right? This is a system in which only additivity is there and none of the others are there. Okay? I'll just give one more example and I'll leave the fifth one to yourself. Construct a system which is only stable and none of the others. Try this. This should not be too difficult. So I want only stability, I don't want shift invariance, I don't want homogeneity, don't want additivity and don't want causality. So in general, if you consider sort of exponential systems, so suppose I take y of t equal to e power x of t. This will easily give you access to systems which are not additive and they are not homogeneous, okay, and this is stable. So now you just need to make it non-causal and shift variant. So to this system you have to make some changes so that it becomes non-causal and it becomes shift invariant, right? So can you do that? Yes, yes, yes. X of 2t plus 1, e x of 2t plus 1. Is it shift invariant? It's not shift invariant, right? T plus 1 or 2t plus 1? I want shift variant. This is shift variant, right? Is it stable? It's stable because if x of t is bounded, then x of 2t plus 1 is also bounded, y of t is also bounded. Is it additive? It's not additive. Homogeneous? It's not. Causal? It's not. Shift invariant? It's not. So this is a good example, which is only stable, it's not any of the others, okay? Correct. And now we'll go the last example. So what is left? Only homogeneous, correct. So give me a system which is only homogeneous and none of the others. So if you want homogeneity and you don't want that, sorry?
d by dt of x of t.
Correct, that is what I said. It's a good example, but I don't want to give that because it assumes your signal is differentiable. I don't want to do that. Now I want to consider any function from real numbers to complex numbers and I want the system to be applicable on that. So if I take something like x of t equal to, I don't know, the unit step for instance, and you say your system is y of t, the derivative of x of t, then it doesn't really make sense, right? So typically if you want x of 2t plus 1, is this stable? I don't want stability, I just want homogeneity, I want none of the others. Essay, still stable, no? See, if you give a bounded input, it should be a bounded output, so that's why it's stable. So if you want, yes, sine of x of t, is it stable? Extremely stable, so no. 1 over x of 2t plus 1. Is it causal? Is it additive? Is it, no, but this is not a system first of all. What happens if x of 2t plus 1 is 0? You have to define that. What is the value if x of 2t plus 1 is 0? You have to give some value, no? 0. Is it causal? No, it's not. Is it additive? No. Is it homogeneous? Yes, because 0 is kept here. If there was anything other than 0, it would not have been homogeneous. So it's homogeneous. Is it stable? It's not stable. And is it shift invariant? No, because there's a factor of 2t here, right? Correct. This is a good example. And in such a way, this is just 6 of the examples that we've considered. Actually, there are 32. So, this is a very interesting problem that you can give to your students, You find all such systems and you convince yourself that actually all these properties are independent. right? So yeah, that is all I wanted to discuss.